Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rusyaidi bin Mazlan, and in this video I will show to you how my system works for the individual assignment 2. So let's get into it. First, click on the local Windows debugger, and after we click the debugger, it will show the main menu, and it will give an option or three options: go to chapter 4, chapter 7, or exit the system. So what if we put a value that other than the option given? Let's say we put 5, and it will display the error text and it will be redirected again to the main menu. So this is my way of error handling. So first, let's get into chapter 4. As for the chapter 4, there are 5 subtopics. So for the first one is data transfer instruction. For the first one is move instruction. For the move instruction, I will say input 5 and it will return the value of EAX. And then for the move CX 3, and it will return 3, and we can see the binary it filled with 0. And then signs instruction. For the sign instruction, when I put negative value, it will fill the remaining bits with 1 that indicates sign negative value. So you can see here, next one is XCSG, exchange instruction. For this instruction, we will be required to insert 2 inputs, 5 and 3, and it will swap the value between the registers. Next, the last one for data transfer instruction subtopic is pair offset operand, and I declared the list array is word, and when I move list to AX, it will return the first value of the array. When I move list plus 2 to the register, it will return the next element. List plus 6, the answer is 8. Let's go back to chapter 4. And the next subtopic is addition and subtraction, number 2. So first, in INC instruction, so when I put any value, it will increment the value by 1. Let's go with 4, it will be 5. And for decrement, it will decrement any value. Let's put 8, it will become 7. And next one is add instruction. It will require us to put 2 values, 5 and 3. It will add the 2 registers value. And then sub instruction, this requires 2 values as well. I will sub 9 by 5. It will return 4. And then an EG instruction, it will change the sign of any value that I insert. Let's go for 8, it will return negative 8. Back to chapter 4. The next subtopic is data related operators and directives, 4.3. So for the first one is offset operator. So for the offset operator, I've been using offset operator for my entire code, so I just print the next text and then PTR operand. So PTR operand, I declared PTR try array as word. So when I move PTR try array to AL register using PTR operand, it will return the first 2 bits only of the value. And then the next one is type operand. And for the type operand, I move type of IPT1 to EX registers and return 1 because IPT1 size is data byte, and the next one is EX equal to 4 because OVRD size is the word. So the next one is length of. So the length of operand is basically the number of element inside. In this case, I put array list 2, and there are 1, 2, 3, 4, 5 element. So let's try. The input I insert will be added with the length of this array. So 5, then it return 10. So 5 plus 5 equal to 10. So the next one is size of. Size of is basically length of multiply the type. So as you can see here, the length of list 2 is 5, and it will multiply with the size of operand list 2. List 2 is the word, so 5 times 4, it will return 20. And then the next one is label directive. So as for label directive, when we declare any memory label, it will return the value of the next declared entity. So you can see it will return the first 4 bits of the label 32 value because it follows the label 16 size. And then let's go back to chapter 4. The next subtopic is 4.4 addressing modes. Let's get into it. So the first one is indirect operand. For indirect operand, I will move the offset of anything I declared into the EDR registers, and then I will move back the EDR register value to AX registers, and then we get the value for move AX EDI. It will return 2, which is the value of list array. And then the next one is 4 because I add ADI by 2, so it return the next value. And then the next one is AX will return 10 because I move ADI by 6. From the 4 it will return 3 next elements. And then the next one is index operand and index scaling. And for the index operand, this is the code, the first 2 lines, and for the index scaling is the last 2 lines. So the next one is pointers. So for the pointers, I will move PNTR to ESI, which the PNTR contains the offset of list array. So this is the value for move AX ESI, and this is move AX ESI plus 2. So let's go back to chapter 4. And the last subtopic for chapter 4 is jump and loop instructions. So for this jump and loop instruction, I make a code that will require the user to insert a value within a range of 1 to 5, and it will look, the value will increment 1 by 1 until it reaches 10, and then it will quit the system. What if I put 6? This is my error handling, and let's go with number 3. So the value is incremented 1 by 1 and it will stop at 10, so it quit the system. So that is for chapter 4. Let's go back to main menu. The next chapter is chapter 7. Let's get into it. First is shift and rotate instruction, and for the first one is SHL instruction, shift left instruction. When I move AX with this value and then I use SHL instruction, it will shift the value 1 bit to the left, so it will become this input. So the next one is force multiplication. SHL instruction is always used as force multiplication, and for this I will require to input. For first input will multiply by 2 power of the second input. 5 multiply by 2 power of 2, which is 4, it will return 20. So the next one is shift right instruction. So if SHL instruction is used for fast multiplication, and so SHR instruction is used for fast division. So input will divide it by 2, let's go with 6, it will return 3. And then SAL and SAR instruction. SAL instruction is similar to SHL instruction, so I will just go into the SAR instruction. And SSR instruction, it works as division as well, so let's just put input 8, it will 8 divided by 2, it will return 4. And then the rotate instruction, first rotate right and rotate left. First the ROR, rotate right. When I rotate the value by 1, it will move to 1 bit to the right, and then the last value here, the least significant bit here, will be copied to the most significant bit. So from 0 it will be copied to here, so it becomes this value. As well as for the rotate left instruction, when I rotate left by 2, it will move to the left by 2 bits, so this is the final value. And then the next one is RCL and RCR instruction, rotate carry instructions. So this is my first value of AL. When we rotate carry left, the most significant bit here will be moved to the carry flag, and the existing carry flag value will be moved to the least significant bit. For these instructions, we need to clear the EDX registers first, so it will work well. So this is the outputs. The next instruction is SHLD, shift left double. So as for shift left double, when I shift left double X and BX, it will copy the most significant bit of the source to the least significant bit of the destination. The X register is the destination, BX is the source. So when I shift left double the value, it will return 3, 4, 5, 6. And then for the SHRD, shift right double, it works just like shift left double, but it works to the right. So it returns 3, 4, 5, 6. So let's go back to chapter 7. And for the next one is shift and rotate applications. For this application, I just use the SHL instruction. So let's go with 8 times 2 power of 2, 8 times 4, 32. Third subtopic is multiplication and division instructions. So first is MUL instruction, multiplication. 5 times 3 will return 15. And then the next one is IMUL. For this instruction, it will reserve the sign for the value. So let's go with negative 3 times 3 will then negative 9. So the next one is the IV instruction, division. So the IV instruction, we will divide the first input with the second input. So 9 divided by 3, it will return 3. And then the last one is the IV instruction. So let's try it with 15 divided by 2, it returns 7, but the remainder is transferred into the other registers. So from here I can go back to chapter 7 or go back straight to main menu. So since we are done with chapter 7 and chapter 4, so let's just go back to main menu. So to exit the system, we choose number 3, and that is all from me. Thank you for your time, and Assalamualaikum.